Now let's talk about integration using completing the square. So let's remind ourselves what completing the square means. So this is going to help us when we have quadratic functions in the integrand. Specifically, we'll usually see them in the denominator. And so you'll notice, for example, like in number 2, it's a quadratic in the denominator, but there isn't anything in the numerator to make like a u substitution. So if I want to complete the square for like a quadratic like x squared plus bx plus c, notice there my leading coefficient needs to be 1. What I would do is have my x squared plus bx, that's going to be the first part of my quadratic. I need to add and subtract b over 2 squared. So whatever my coefficient on the x is, divide it by 2 and square it. I'm going to both add and subtract that to balance it out, and then I have my plus c separately. That will help me rewrite this as a perfect square, x plus b over 2 squared, and then I'll have minus b over 2 squared plus c, so I'll combine those two. Let's see what that looks like. So we have in number 2, dx over x squared minus 4x plus 8. My usual techniques of maybe this is inverse trig, it's not apparently right now. I can't do a u sub because there's no 2x minus 4 or a constant of that. So that tells us that we'll probably use completing the square. So what we'll do, we'll rewrite, we've got the dx. I'm going to focus on this x squared minus 4x. I'm going to try to make that into a perfect square. So I'm going to write this plus 8 over here. So what I need to do is negative 4 divided by 2 squared. B over 2 squared. So negative 4 over 2 is negative 2 squared is 4. So I'm going to add 4 here, but that means I need to subtract 4 outside to balance it out. What this gives me then, x squared minus 4x plus 4 is x minus 2 squared. It's x plus your b over 2, right? This is your formula, b over 2. So whatever you got here, the negative 2 squared, that was negative 2 squared, that's where this minus 2 comes from. Now I still have the minus 4 plus 8. I can combine those to give me plus 4. So I have the integral now of dx over x minus 2 squared plus 4. This is a format we should recognize. It's the inverse tangent. So remember when we have dx over a squared plus u squared, sorry, that should be a du. Our formula was 1 over a arctan of u over a plus c. And so my u is x minus 2. The derivative of that is just 1, so I don't have to formally write out my u sub. My a squared is 4, so my a is 2. So I'm going to have 1/2 arctan of x minus 2. Make sure you don't put that square on there, it's just the u part, over 2 plus c. For number 3, we have the integral of 10 over square root of 8x minus 4x squared dx. Now what you might notice is that there is a coefficient on that x squared, which we don't want if we're completing the square. So we're going to have to factor that out. So I can factor out a 4 from both of those terms. So I have 4 times 2x minus x squared, which I can rewrite as 10 over, now here I have to take the square root of 4, 2 square root 2x minus x squared. And so then I can simplify just a little bit more, 10 over 2, 5 over square root of 2x minus x squared. Now I'm almost ready to do my completing the square. And I also notice that I have a negative here. I'm subtracting that, so I will want to factor out that negative. Factor out any other constants first, and then you can think about your negative. When we have the square root in the denominator, you will have a minus x squared usually on these problems. So I'm going to rewrite this as 5 over square root. I'm going to factor out the negative, x squared. Now, if I factor out a negative from both of these terms, that's going to make this a minus 2x. I'm going to leave a space here so I can complete the square. So my b is negative 2. I'm going to do negative 2 over 2 squared. That's negative 1 squared is 1. So I have to add 1 here. Now when I add 1 inside here, I'm actually subtracting 1 from the overall term underneath the radical because of this negative sign out in front. And so outside of that part, I'm going to have to add 1 as well. That will balance everything out. So that gives me, now I'm gonna rewrite this, or just reorder it, square root of 1 minus x minus 1 squared. Again, that minus 1 comes from the negative 2 over 2 that we were looking at. Now this is in the form of arc sine. My u is x minus 1. The derivative of that is just 1, so I'm good to go there. And then 1 is my a squared, so my a is just 1. So this will give me 5 arc sine of x minus 1 plus c.